Hello, Kyle from Pure Storage here, and in today's demo we're going to show you just a simple example of how you can use dynamic versus static provisioning within VMware Tanzu. There's a couple prerequisites here. We've already set up workload management and we've already set up a Tanzu Kubernetes cluster within workload management, so we're going to go ahead and authenticate against it right now. If you watch the previous demo video, this is where we left off. Now that I'm into this Tanzu Kubernetes cluster, I'm going to assign a cluster role, binding role against it, which basically enables any authenticated user to do things like create deployments, et cetera, et cetera. So the first thing we're going to look at is our persistent volume claim. So this is going to be our example of dynamic provisioning. So we've got a name, it's assigned to a storage class, and then we've got 5 gigs of storage that we want to request. That CNS-vvols policy was inherited to this TKC via namespace storage assignment. We go ahead and apply it, and if we look at the look at the vSphere in the background there, we can see that container volumes are indeed being created. So if we look at the persistent volume and the persistent volume claim, we can see all of that information in our YAML file has been passed here, and a persistent volume has indeed been dynamically provisioned. So if we look specifically at that persistent volume, we can see that the default reclaim policy is delete. So what I'm going to do here is go ahead and patch it so that it has the retain policy, meaning that if a pod it's associated with or the persistent volume claim that persistent volume is bound to is deleted, that persistent volume will be retained. Okay, we've got that patched. So now when we look at it again, we can see that that reclaim policy is now set to retain, which is what we want for this demo. And if we look at vCenter itself, we can see that our persistent volume claim is indeed showing up there under container volumes, and that flash array vvol data store is what it is residing upon. So now if we look at our MySQL deployment YAML file, we can see that down at the bottom there, we actually do have that same persistent volume claim referenced. For what it's worth, you could certainly create that persistent volume claim within this YAML file. I just broke it up to make it a little easier to see what's going on here. So in this namespace right now, we have no deployment, so we're going to go ahead and deploy that MySQL deployment within it. So that MySQL deployment has been created. It does take a few seconds for it to come up, but we can see it's now ready. This is a very small, very simple MySQL deployment. And what we're going to do next is actually expose this deployment via a service to give it an external IP address that we can then log into. So we've exposed the service, and as we can see under the external IP setting here, or area field, excuse me, we can now authenticate against that IP address to get into this MySQL instance. Okay, now that we're in, almost in, we're going to go ahead and, so we've got a default set of databases. It's worth mentioning that these databases are all mapped to that persistent volume claim that we created earlier. So we're going to just go ahead and create a database called TPCC, and then we'll as we can see, that database is now created. We're going to use it, and then we're going to restore just a really small HammerDB backup database to it. There's a MySQL dump file that we're restoring. Again, really small. This is just simply for demonstration purposes. So now if we look at the tables that are within this TPCC database, we can see there's a bunch of different tables within there, and we'll go ahead and exit. So now to give an example, and basically that's an example of how to dynamically provision a persistent volume. What we're going to do now is actually take that persistent volume and reuse it in a different MySQL deployment. So we'll start by deleting our service to get rid of that external IP address, and then we'll go ahead and delete that original MySQL deployment. So that MySQL deployment is now gone. And we can see in the background the container volume is being unbound from that pod as well. But we can see that persistent volume claim still exists, as well as the persistent volume. So because of that retain setting here, we could also delete that persistent volume claim if we wanted to, and then bind that persistent volume to a new persistent volume claim. But for time, we'll not do that. Instead, what we're going to do is we'll rename this deployment to MySQL 2. It will still use that same persistent volume claim we originally created down at the bottom, and we'll go ahead and deploy it. Okay, so now we have a deployment named MySQL2 that's been created. Nope, still waiting for it to come up. Just give it a second here. There we go. So now it's ready. Same as before, we will expose that MySQL instance via a service so that we can authenticate against an external IP address. So now that we're logging in against this MySQL instance, what we're going to see is rather than it just being a generic blank persistent volume, that TPCC database that we created earlier does indeed still exist. If we actually dive into it and use it and then show our tables, all that data that we created previously has been indeed statically provisioned and attached to this MySQL database. Thank you for watching. Please check out the VMware Platform Guide for more detailed information about Tanzu and everything else VMware. Thanks a lot for watching. See you next time.